Hello friends, welcome back to our channel. Today we are going to learn how to draw the shear force diagram and bending moment diagram for the given cantilever beam. Here 4 point loads are acting on the beam and their distance is given from the free end. Let us draw the cantilever beam with the given point loads. First draw a line. We are not drawing the beam to any scale. This is the fixed end of the cantilever beam. It is given as 0 meter, so the first point load acts at the free end. 3 kilonewton point load is at the free end B. Next point load 2 kilonewton is at 1 meter from the free end, so mark a point as 1 meter from the free end. 2 kilonewton. The distance is 1 meter from B. Next point load 2 kilonewton is at 2 meter from the free end, so mark a point. Last point load 3 kilonewton is at 3 meters from the free end. Mark a point and draw the point load. Draw light lines as shown. Draw a horizontal line for the shear force diagram. Let us calculate shear force at each point. We can find the shear force easily if we consider the right side and left side of the point load. First, let us find the shear force at point B and towards the right side. There is no point load towards the right side, so the shear force will become 0. Now consider the left side of point B. When we see from the left side, we can see there is a point load 3 kilonewton towards down. So it is minus 3 kilonewton. If the load is upwards, it will become plus. But it is downward, so it is minus. Now consider the E right side. From the right of E, only one point load is there, that is 3 kilonewton. So answer is minus 3 kilonewton. Now when we see from the left side, there are 2 point loads. Minus 3 kilonewton and minus 2 kilonewton. Minus 3, minus 2. So minus 5 kilonewton. Now D point on the right side. When we see from the right side, there are 2 point loads, 3 and 2. Minus 3, minus 2, we will get minus 5. When we see from the left side of D, we can see 3 point loads. So minus 3, minus 2 and minus 2, we will get minus 7 kilonewton. From the right side of C, there are 3 point loads, minus 3, minus 2 and minus 2, we will get minus 7 kilonewton. Now from the left side of the C, we can see 4 point loads. -3, -2, -2 and -3. we will get minus 10 kilonewton. And finally from the point A, that is the fixed end of A, we can see 4 point loads, minus 3, minus 2, minus 2, minus 3, total minus 10 kilonewton. Let us draw the shear force diagram. At point B, we have 0 and from the left side minus 3. So draw a line showing 3 kilonewtons towards downwards. When the point load is downwards, we will get the shear force diagram downwards. Next, right of E is minus 3. Minus 3. Next, on the same E point, we are getting minus 5. Draw one more line representing minus 5. Next, at D point, minus 5. And minus 7 kilonewton. As it is downwards, no need to mention the symbol minus, simply we can write the 7 kilonewton. Same at C point, we are having 7 kilonewton and 10 kilonewton. Draw a point as 7 kilonewton and one more as 10 kilonewton. Next, at A point also 10 kilonewton. Draw a line. This is our shear force diagram. Let us find the bending moment at each point. Bending moment is equal to the load into distance. So first bending moment at B. So at B the load is 3 kilonewton and distance is 0. So it will become 0. Bending moment at E, 3 kilonewton into and the distance is 1 meter. We will get minus 3 kilonewton meter. Bending moment at D. On the D we can see there are two loads on the right side, minus 3 into distance is 2. Next minus 2 into the distance is 1 meter. So we will get minus 6 minus 2, minus 8 kilonewton meter. Bending moment at C. So there are three loads on the right side. First is 3 kilonewton at a distance 3 meter. Next 2 kilonewton at a distance 2 meter. And 2 kilonewton at a distance 1 meter from C. So we will get 3 3s are 9, minus 4 minus 2, we are getting minus 15 kilonewton meter. Bending moment at A, we can see there are 4 loads towards the right side, minus 3 into distance 4 meter and 2 into distance 3 meter, next 2 into distance 2 meter, 3 into distance 1 meter. We are getting 25 kilonewton meter. Let us draw the bending moment diagram. So as there are only point loads, we can draw straight lines in the diagram. If there is uniformly distributed load, that is UDL, we will get a curved lines. At B point bending moment is 0 and at E point bending moment is 3. So mark a point as 3. Draw a straight line. Bending moment at D is 8. So mark a point as 8. Draw a line. Next at C, 15 kilonewton meter. Similarly, mark the remaining points and draw the lines. This is our bending moment diagram. Thank you so much for watching this video. Please like, share and comment. Subscribe to our channel. Bye bye.